Another day, another story. Saturn, the sixth planet from the Sun, is renowned for its extensive system of rings, but it is also remarkable for having a large number of moons. Saturn has 83 confirmed moons, though this number could increase as further observations are made and new moons are discovered. These moons vary greatly in size, composition, and orbit. Here's a look at some of the most significant ones. Welcome to Turbo Eminent Channel. Titan. Titan is the largest of Saturn's moons and the second largest moon in the solar system, only smaller than Jupiter's Ganymede. It is larger than the planet Mercury. Titan is unique because it has a thick atmosphere, mostly of nitrogen, with small amounts of methane and other complex hydrocarbons. This atmosphere is so dense and the surface pressure so high that liquid hydrocarbons can exist on the surface in large lakes and rivers. Enceladus. Enceladus is much smaller than Titan but has attracted a great deal of attention because of its active geysers. These geysers shoot ice particles and vapor from beneath the Moon's icy surface into space, suggesting the presence of an underground ocean of salty water, which might harbor conditions favorable to life. Rhea. Rhea is the second largest moon of Saturn and is made primarily of ice with a smaller proportion of rock. Its surface is heavily cratered and covered with bright wispy streaks that are thought to be material ejected from its interior. Iapetus. Iapetus is famous for its striking two-tone coloration. One hemisphere of the moon is very dark, while the other is quite bright. This dramatic contrast is thought to be caused by material from another of Saturn's moons, Phoebe, coating one side of Iapetus. Dione. Dione has a mixed surface of heavily cratered regions and younger, relatively smoother areas. It also has bright, wispy ice cliffs which may have resulted from tectonic fractures. Tethys. Tethys is known for its enormous crater named Odysseus, which is about 450 kilometers wide, and a large valley called Ithaca Chasma, stretching about 3/4 of the moon's circumference. Mimas. Mimas is perhaps best known for the Herschel crater, which gives it a resemblance to the Death Star from Star Wars. The crater is so large in comparison to the moon's overall size that it's surprising the impact didn't shatter Mimas. Hyperion. This moon is notable for its irregular, spongy appearance. It rotates chaotically due to its irregular shape and the gravitational influences of Saturn and Titan. Phoebe. Phoebe orbits Saturn in a retrograde direction and much farther out than most of Saturn's other moons. It is thought to be a captured centaur, a small icy body from the outer solar system, and has a dark, carbon-rich surface. Titan, the mysterious moon with an atmosphere. Titan stands out in the solar system as the only moon with a significant atmosphere. This dense, nitrogen-rich atmosphere is laced with organic molecules, creating a thick orange haze that obscures the surface from view. Titan's surface, as revealed by the Cassini-Huygens mission, includes vast lakes and seas of liquid methane and ethane, river channels, and dunes made from organic sand. This makes Titan one of the most Earth-like worlds we've encountered, albeit with a much colder environment. Enceladus, a small moon with big surprises. Enceladus has captured the imagination of scientists and the public alike. Despite its small size, Enceladus exhibits activity that is highly unusual for moons. The geysers at its south pole, shooting water vapor and ice particles into space, originate from what is believed to be a global subsurface ocean beneath its icy crust. These plumes contain organic compounds and evidence of hydrothermal activity on the ocean floor, conditions that could potentially support microbial life. Iapetus, the yin-yang moon. Iapetus is fascinating not only because of its drastic color dichotomy but also due to its equatorial ridge, which makes it resemble a walnut. This ridge runs along the moon's equator and rises up to 20 kilometers high, stretching over 1,300 kilometers. The origin of this ridge remains a mystery, with theories suggesting it could be the remains of a collapsed ring or the result of ancient convective overturn. Phoebe, the captured moon. Phoebe's irregular orbit and composition suggest it was not originally part of Saturn's system but was captured by Saturn's gravity. Its surface is pockmarked with craters, and its dark coloring suggests it contains a high amount of carbon, unlike the icy surfaces of Saturn's larger, regular moons. Phoebe provides clues about the primordial materials that existed in the outer solar system, offering insights into the processes that shaped the early solar system. Future exploration and potential habitats. Titan and Enceladus are prime candidates for future missions due to their potential to host life and their unique geological phenomena. Titan, with its thick atmosphere and surface lakes of hydrocarbons, presents a rare opportunity to study an environment radically different from Earth. The upcoming Dragonfly mission, a drone designed to fly Titan's dense atmosphere, aims to explore its diverse landscapes and potentially even search for biosignatures. Enceladus, meanwhile, offers a shortcut to exploring a subsurface ocean, thanks to its geysers that spew samples into space. A mission that could fly through these plumes and analyze the ejected material could potentially confirm the presence of organic chemistry or even biological activity. Theoretical insights and cosmic puzzles. Iapetus and Phoebe provide case studies in the more unusual dynamics and histories of moons. Iapetus' extreme albedo dichotomy and its equatorial ridge challenge our understanding of geological and orbital dynamics. Theories about its rich and dark hemisphere involve complex gravitational interactions and possibly ancient ring systems, offering test cases for understanding similar features elsewhere in the solar system. Phoebe, likely a captured object from the Kuiper Belt, gives scientists a tangible example of how the early solar system was populated with material from further out in the cosmos. Studying Phoebe helps refine our understanding of how material is distributed across the solar system and the processes by which planets and moons capture wandering bodies. Interplanetary pollution and ring dynamics. The interactions between Saturn's moons and its rings also offer a dynamic field of study. Enceladus directly influences the E-ring, while Phoebe likely contributes dark material to Iapetus. These interactions demonstrate how moons can play a significant role in the structure and appearance of planetary rings and how they exchange material. Such processes are not only important for understanding Saturn's system but also for how exoplanetary systems might behave. Cultural and philosophical impact. Beyond science, the exploration of Saturn's moons impacts culture and philosophy. Titan, a world with rivers, lakes, and potentially rain, all of methane and ethane, challenges our Earth-centric concept of what a world can look like. Enceladus poses questions about the ubiquity of life. If a small icy moon can potentially support life, how common might life be across the universe? Conclusion. Each moon of Saturn tells a unique story and adds layers to our knowledge of the cosmos. As robotic explorers continue to send back data, and as future missions are planned and executed, our understanding of these distant worlds will expand. These moons are not just points of light in telescopes but worlds as complex and fascinating as Earth, each holding the potential to reshape our understanding of the solar system. Thanks for watching. Request you to subscribe the channel.